Thanks for joining me today in this talk about Google Maps and Jetpack, how to use it with Jetpack Compose and how to draw on the Google Map using Jetpack Compose. I'm Luca. I'm an Android engineer currently living in the UK. I recently started a YouTube channel where I have a series related to Google Maps with Jetpack Compose. So if you miss something about the presentation, feel free to reach out to the YouTube channel and watch the videos. And that's my X handle. I'll be posting the slides of the presentation later on after this talk. So if you want to connect there, feel free to do. So yeah, back on the topic, how many of you are actually using Google Maps in their project? Right, with Jetpack Compose? Not all of you, okay. I never work with Google Maps without Jetpack Compose, so this talk won't be a comparison of the two way of using Google Maps. And by drawing on Google Maps, I don't really need this thing, even though it's possible with what we have at our disposal. So initially, Google Maps wasn't available for Jetpack Compose, and the only way to use Google Maps was to embed it into an Android view composable function. Now we have map in Compose, which has been split into 3 libraries. The version is actually 5.0.4 right now. There has been small updates since I started working on this talk. So the main library is the Android Map Compose and contains the Google Map composable function, how to control and configure the map, almost everything drawing related, so marker windows, circle, polygon polylines, and overlays. Then we have the Compose utility library, which has the clustering in it. And the last one, which is an additional one, has the Compose widgets for the scale bar and disappearing scale bar. So this is the signature of the Google Map composable function. It has a lot of parameters, as you can see. And the most important one is the content, which accepts a composable and composable map composable body, which is what is going to be drawn on the map. You can customize the map in a few ways by using the properties, which is some map properties and the UI setting. The map properties has a few parameters, and if you want to change how the map is displayed, the one that you're looking for is the map style option. There is a styling wizard, which is deprecated. More on this later on. You can head over the link there and pick from one of these 6 styles pre-built for you and customize all of them. You can customize quite a few things, administrative things, landscape, points of interest, roads, and water. And for every single voice here, you can customize the fill color, the border color, and the labels, both with the text color, stroke color, and the icon. Once you're done customizing the style in the wizard, you can export it as a JSON, and then you can load the JSON by using the map style option, load raw resource style, providing the context and loading the JSON file. But this is the deprecated way to style a map. Right now, you should be using the Google Map option factory, providing the Google Map option map ID. The map ID is, you should gather the map ID from the Google Cloud Map console. And the map UI settings instead lets you control both how the user can interact with the map via gestures and also starts to draw something on it. We have the compass enable, which shows the little compass on the top left of the screen, only if the map is not pointing north. Then we have the map toolbar, which is the small bottom right icons shown only if a point of interest is actually selected from the user. We then have the My Location button that centers the position of the map on the user location, and the zoom controls that are displayed there in order to zoom in and out of the map. But all of this is basically configuration of the map and a little few of drawing on the map. The most common thing that many of you would like to use in a map are markers and cluster. Markers are basically just this thing. We all have seen them. You usually use them to place, to notify the user that there is something of interest in a given position of the map. The markers can be used by using the standard icon. You can customize the standard icon using different hues. You can completely use a custom icon entirely, and you can also customize the info window, which is what is displayed when the user taps on a marker. This is the composable Google Map composable marker function. If you want to place a marker on the map, what you need to do is provide a state. The marker state contains a position, which is a latitude, longitude position, that allows you to specify where the marker will be placed. If you want to customize the icon, but using the default one and only changing the color, you can do so by using the bitmap descriptor factory.default marker and providing a hue. We have a few hues at our disposal that we can use, and those are just a few of them. If you want to use a completely custom icon, you need to provide a bitmap descriptor, so you can provide just a drawable resource. This is a simple function that gets a drawable, creates a bitmap from the drawable, draw the drawable on the canvas, and returns the bitmap by using the bitmap descriptor factory from bitmap function. And this is how you could use the bitmap descriptor function that I just showed you to use to customize the icon entirely of a marker. What you want to pay attention to is also the anchor of the marker, which is where the custom icon will be start to be drawn on the map. If you're using an icon that has a pointy thing, like those ones, you want to maybe play around a bit with the anchor in order to have the point placed on the right position. If you want to display something when the user taps on a marker, you want to use the marker info window function. This is to be used in place of the marker one. It draws the marker by default and then handles the content, which is a composable function that you can customize entirely. It sets a state as the marker to place it in the correct position of the map. You can specify a snippet and a title. The snippet is just the description. If you provide those and don't provide any content, the default one would be used. Otherwise, you can use the lambda as the content and specify whatever you want inside there to be used as the marker info window of the marker. The one on the left is the default one if you provide a title and description, and the one on the right is the custom one that was shown on the code here, just a column with two texts and an image. If you have too many clusters too close together, they may overlap, and you want to avoid it. To avoid that, you can use clusters. Clusters group markers by distance. You can fully customize the tab handlers on everything, cluster and icons. And you have full control of the graphics for both the cluster item and the marker item. To use cluster, you need to use a cluster item, which is an interface that requires you to specify the position. The position is the only parameter that you have to provide. It can be null. All the other three, so title, description, and the Z index can be null if you need to. This is just an example of how to implement that interface. We have location, name, description, and the Z index. And this is the clustering composable function. It accepts, the first parameter is the items, which is a collection of that interface that we just showed, the cluster item. You can customize the click on the cluster, the click on the cluster item, which is the single marker itself, the click on the info window, and the long click of the info window. And then you can specify a cluster content and a cluster item content, which are UI composable function. One receives a cluster, and one receives your data of cluster item. This is the default implementation, which is used if you don't specify the cluster content and the cluster item content composable function. The cluster is rendered by drawing a circle on the map and placing a text inside of it, with the number of markers grouped together in that area. And the marker is using the default info marker icon. And this is a default one. I just did some changes to display 2 rectangles instead of the circle and the marker icon. If you want to customize, for example, just the cluster content, which is the group together, but you want to use the default marker for the marker, you don't want to specify it yourself, because the cluster item content, if you do something like this, you get a nice exception, which is an invalid applier. And that's because both the cluster content and the cluster item content accept a UI composable function, while all the functions from the Google Map Compose library are marked as Google Map composable and can only be used inside the Google Map content function. For drawing shapes on the map, we have circles, polygons, and polylines at our disposal. Let's start with circles. Circle requires you to specify a center, which is a latitude and longitude, to place the circle there. Pay attention to the circle composable function because it defaults to a transparent color and a radius of 0. So if you just specify the center, you won't see anything on the map. I opened an issue on the Google Map composable function to change this in order to require a radius to be provided and defaulting to color black, as all the other composable functions use the color black as default parameter. If you specify a radius and a color, you can draw circles on the map quite easily. Circles allows you to change the fill color, the radius, stroke color, so the border width, and the pattern of the border. For example, the code that I just showed you yields this result: red circle, blue border with a style border. If you want to hide the border, you have 2 options. You either define the stroke color to be transparent or the stroke width to be 0. And if you want to apply transparency to the circle composable function, you have to do so by applying an alpha to the color that you're using, both to the fill color and the stroke color if you're using both of them. And yeah, that's a half transparent circle on the map. Polygons, it's a little bit more complicated, but not too much. It accepts points, which is a list of latitude and longitude points. It defaults to color black, and just by defining some points on the map and using the polygon composable function, providing them, you get the default implementation of the polygons. You don't need to specify the polygon composable function closes the polygon for you, so you don't have to duplicate any points to be the first and the last one of the list. You can change the fill color and the stroke width of the polygons. This is what you get when you start customizing it a little bit. You can also change the stroke pattern, as we've seen for the circle composable function. This is with a bit more of customization. And here again, if you want to change the transparency of the polygon on the map, you need to apply the transparency on the color. The code here shows the transparency only applied to the fill color and not the stroke color. And as you can see, the border is full color while the polygon has a transparency on it. The polygon composable function also allows you to define a holes parameter, which is a list of points. If you define just one list of points inside of the holes, you get a hole inside of the polygons. The stroke configuration is used for the inner border as well. If you define multiple lists inside the hole, what you get is basically multiple holes inside of the polygon. The order of the points matters, so you need to pay attention to how you order your points, otherwise you might end up having something like on the first, on the image on the left, which you might don't need to. Polylines is really similar to polygons. The only difference on what is drawn is that the points are not closed, so if you want to draw a line that closes, you have to duplicate one point, being the first and the last one. And here again, the only required parameter is the points. So you can do something like this, and you get the default implementation of the polyline. Polylines lets you customize as well the color and the pattern of the lines, and also the start cap and end cap of the polyline. This is actually a custom start and end cap. You don't see it here, but if you increase the width of the polyline and zoom it as much as you can see that one is using a rounded cap, one is used a square cap to end the line or start the line. Another thing that you can customize in the polylines are the spans. It's basically change the colors of the lines point by point. So here I have a list of points, which is a list of 4 points and only a list of 2 spans. And the result will be that the changes is being applied from the first to the second point, and then it just keeps the last one that you specify. Another cool things that you can do in the list of span is that you can build a gradient. So you can choose 2 different points. Here as well, you can, if you want, specify a gradient for every single point. I didn't, just one with one. And if you specify just one gradient, it's applied on the entire polyline, not just from the first and second point. So the gradient is used nicely on the entire polyline. And that's it for shapes. Now let's talk about overlays. This is the most complicated things that you can use on Google Maps. We have 2 ways of using overlays. One is ground overlay, the other one is tile overlay. The ground overlay requires you to specify a position, which is not a latitude and longitude, but it's a ground overlay position, and then image, which is again a bitmap descriptor. Sorry, one thing, the anchor is specify where the image is gonna be started to draw, the top left corner of the image compared to the position. The bearing is the orientation of the image that you provide. And so for the position, you need a ground overlay position. There are 2 ways of creating a ground overlay position. You can either specify a location, latitude and longitude, the width and the height of the overlay. The location would be the top left corner of your overlay, and then it calculates the overlay based on the width and the height. Otherwise, you can specify a latitude, longitude bounds, and to specify them, you need the southwest point and the northeast, so bottom left, top right. Here again, the anchor is quite important, and the ground overlay lets you use a transparency, so you don't have to apply the transparency to the image itself. You can just apply it entirely to the ground overlay. The drawable to bitmap descriptor, it's a function really similar to the one that I showed you before. Just get the drawable, creates a bitmap, draw the bitmap on the canvas, and here just to have it displayed properly, I had to scale the canvas in order to display the image. So if we get a ground overlay, which is the underground of London, and we place it on the map with a lot of calculation to get the perfect top left corner of the image and place it in a latitude and longitude. I was able to kind of get a acceptable solution. It's not really precise, but yeah, the scale was for this one. And as you can see, it applies a transparency as well. You can handle clicks on the overlay, and you could rotate it as well if you need to. Now, tile overlays are the more complex if you handle them yourself, and the easiest if you don't. Tile overlay, so yeah, there's two ways of handling a tile overlay. A tile overlay requires you to provide a tile provider, and it's the only required parameter that you have to provide. You can choose if the image is faded in or not. You can apply a transparency, and you can handle the on-click of the tile overlay. As you can see, this one, the tile overlay and the ground overlay as well, has a z-index parameter. So Maps knows how to render them one on top of the other if you specify multiple of them. The tile provider is an interface that requires you to implement the getTile function and gives you a no-tile tile, which you can use if you don't want to provide a tile for a specific input. The input that you get is var1, var2, var3, which are basically the X, Y, and zoom of the tile that you need to provide. Tiles are basically squares, representation of the Earth. You would need to flatten out the map on a 2D plane, divide it by square, and provide the correct image representation for that specific square every time that the getTile function is provided. Google gives you an example for the tile provider, which is a coordinate tile provider. Here is just a bit of initialization of the tile overlay provider. It creates a border to draw the border of every single rectangle. And then inside the getTile function, as you can see, you receive the X, Y, and zoom. It draws the coordinates on the tile, creates a byte stream, a byte output stream array, compress the canvas, the bitmap in the stream array, and returns a tile for that specific area. The draw tile coordinates just gets the X, Y, and zoom, writes them on the canvas, and returns the canvas, which is a copy of the border tile. So basically, it draws the border on every single tile that is going to return. And this is what you get. For example, X7, Y5, zoom 4, or 2200, 1300, 43, and zoom 12. As you can see, the coordinates that you get are not coordinates as latitude, longitude. This is because the tile overlay uses the Mercator point. You need to flatten out the map on a 2D plane, and at zoom 0, the tile at zoom level 0, the entire world is rendered in a single tile. The tile at 0, 0, if you have more than one tile, it's the northwest corner of the map. At zoom level 1, the map will be rendered in a 2x2, so 4 tiles. And then the number of tiles is 2 elevated to the zoom level by 2 elevated at the zoom level. So if you have an image, for example, and you want to translate it into tiles, you would need to know exactly which section of that image needs to be returned for a specific tile every time. That's why it is really, really complicated. But you can have a way more simple way of using a tile provider, which is by using the URL tile provider. The URL tile provider is a subclass of the tile provider. that requires you to just specify the getTile URL function where you need to return an URL. As you can see, the implementation is really simple. That's because all the calculation of what image to be displayed is handled by a backend or a service. You just need to build the URL the correct way. The service I'm using here, for example, wants the parameter in the order zoom x and y instead of x, y zoom as it returns from the getTile URL function. But with a bit of tweaking, you can get to a really nice implementation. There are a lot of services online which you can just Google search a few of them. Those are a few I found. And the second one is the one that I've been using for those images. It just draws the United Kingdom. As you can see, as soon as the Google Map requires an area outside the tile, the URL tile overlay returns a no tile, so nothing is drawn. I also remove all the styling from the map in the first screenshot in order to just have the tile displayed on the map, which you can do with the map style option. And on the second one is the same tile overlay, just zoomed in a lot. It changes because the service changes how the rendering is done based on the zoom level. So you don't have to do literally anything, just provide and build the URL. And as you can see from the second image, you can use multiple things together inside the Google Map composable content body. In this example, I just used the tile overlay, the URL tile overlay that I showed you before, and the coordinate tile overlay. But you can use all of them together. You can use circle, polyline, polygons, ground overlay, tile overlay, marker, clustering, everything together. This is an example of multiple things. There is the URL tile overlay, the underground ground overlay, and a few markers. And yeah, that's basically all you can do with the Google Maps composable function. There are some issues with recomposition. So if you have a lot of data, Jetpack Compose tends to recompose the entire Google Map composable function every time the data changes. So you can get a laggy map. I still haven't found a solution for that. I hope that with the strong skipping mode that we recently received, that recomposition will be avoided. And that was all for me. I went too quick. Do you have any question?